Once again, welcome you all for this class. We are basically we are learning some problem solving techniques, and in these problem solving techniques, we are up to this point where we have calculated direction and magnitude of the force which is acting, and which is the magnitude of 3 to 4 forces acting, and making some angle along x-axis. And after resolving this force, we are heading towards other problems of this type of the chapter, other topics. That is, if you look at here is another problem, but it is the magnitude of the forces provided by the sport A and B, as shown in balance condition. This is A and this one is B. So balance condition, it is balanced. The weight of the plant is 500 Newton and it's uniform in shape. The weight of the block is 100 Newton and the weight of the student is 5 Newton. So these are the given. So the weight, what you are asked, the magnitude of forces provided by A and B. You are asked to find out the magnitude of the forces provided by A and B when these weights are acting in downward. One is the 500 Newton, that is weight of the plant. Here the weight of the boy, that is 100 Newton block, and then this is the weight of the student, that is WS, it is 500 Newton. How many weights are acting downward? This one is student's weight, this one is plant weight, and this one is the weight of the block. So what type of forces are provided by A and B? What will you do? These are the forces. Basically, this is force 1, this is 2, block, this is student's weight. So what it is A plus B is equal to what? What amount of the forces are acting provided by the forces. So if it is equilibrium, then of course this will be the condition, that is the force A and B. If these are the two forces acting in upward direction, these three forces are acting in downward direction. So these two are three and two are opposite to each other. So that's why you will indicate with the sign, because it is at equilibrium condition. So that's why they are equal to 0. So after simplifying it, that is FA, force of the A, and force of the B, that is equal to W1 plus WB plus WS. So putting the values, you are getting basically 1100 Newton. Thus the sport A and B provides a force of 1100 Newton. How you have calculated? By using the techniques like equilibrium, the number of forces acting in upward direction must be equal to the number of forces acting in downward direction. So that's why how you have calculated, we have used the equilibrium condition. So after application of equilibrium condition, we have calculated the number of the forces acting up and down. So these are the two forces which are acting in upward direction. Suppose they are plus, when the weights are acting in downward direction, these are opposite to each other. So this is the sum of all forces equal to 0 because it is in equilibrium. So then you have simplified it, and after simplification, you have placed the values to sum up the forces acting, total number of forces acting on A and B. So you can know this will be the total amount of the forces acting in this case. So with this, thank you very much for your patience and hope you have understood.